All right, so we are to our final lesson in Chapter 4, and it's 4.7, Congruence in Overlapping Triangles. And you saw some examples of this in 4.5, where we talked about isosceles and equilateral triangles. So our objective in this lesson is to identify congruent overlapping triangles and to prove two triangles congruent using other congruent triangles. So our proof part of geometry isn't quite done yet. So I kind of faked you guys out before. I wouldn't say I lied to you, but we're going to do a few proofs in this lesson, and we're going to practice some proofs in this lesson. Not writing them out fully in the practice, but completing them. So example 1, we're identifying common parts. So we have two overlapping triangles here. It says, what common angle do ACD and ECB share? The easiest way to do this is to redraw ACD. So I'm going to do my best to redraw ACD. So A to C, C to D, and then D back to A. So that would be A, C, D. That's the best I can do. So that's the triangle kind of on the left. And then ECB is going to be E to C to B, and then back to E. So I know that I didn't do a great job of drawing these as congruent or anything like that. But basically, this helps me visualize which angle they share. Angle C is the angle that they share. So I'm going to say angle C. Now, the easiest way for me to tell which angle they share is if I look at the statements for each of the triangles, how they're named. Both triangles contain vertex C. So I can say they share angle C. So I wanted to throw in a guided practice to get you guys to have some practice redrawing triangles and then finding the common sides between those two triangles. So A and B do two different things. So pause the video, redraw the triangles for A, redraw the triangles for B, and see the common sides that those triangles have. When you're ready, resume the video. So, by redrawing the triangles, I was able to pick out that ADB and DCA share side AD. All right? Now, maybe you could have done this without redrawing the triangles, but I think sometimes that helps. It helps you to visualize each triangle separately when they're not overlapping. So AD for part A, AB for part 2. The overlap of ABD and BAC is AB. And you can see that they share those two vertices, so they share that side, okay? They share that side AB. Now, practicing that is going to help us use common parts to do some proofs. And I know that I talked about that CPCTC, that mouthful before, but we're going to come back to that just a little bit to help us explain how to describe overlapping triangles. So I'm going to start this proof like just about every other one. Start with what's given. Angle ZXW is congruent to angle YWX, because that's given. Also, ZWX is congruent to YXW, also because that is given. Now the tricky part is looking at these triangles as overlapping, being able to redraw them or think of them as having a common side or a shared side, and then being able to use triangle congruence to prove something. So if you look at these triangles, I'm going to trace them and then erase. So ZWX is this triangle right here, okay? That's ZWX. Now I'm going to use a different color to trace the other triangle. So I went from ZWX to Y. Maybe I'll use red. It's a little bit more different. To YXW. So that should be pretty apparent which side is common between them. WX is congruent to itself, WX. So that's that reflexive property coming back. Now, this is where us redrawing the triangles really should be able to help us out and identify how to say these triangles are congruent. So I'm going to draw ZWX. ZWX is this triangle. ZWX. The other triangle, I'm going to draw, it's red. I'm going to do YXW. Oop, wrong pen. YXW. All right. YXW. Now the part of this that's interesting to me is labeling what's congruent. We established WX is congruent to itself. We were given ZXW is congruent to YWX. So I want you to see where I drew those little blue markings. Also, ZWX, I'm going to use two markings, is congruent to YXW. So, with all that being said, we can say that these two triangles are congruent. ZWX is congruent to triangle, we got to do it in the right order, YXW, and I'm going to say they're congruent by ASA. They're congruent by ASA, angle side angle. We were, from the jump, trying to prove ZW is congruent to YX. The reason I can say that is we already proved the triangles are congruent. If two triangles are congruent, their corresponding parts are congruent. So corresponding parts, I'm going to abbreviate that. Corresponding parts are congruent. That's all I would say. That was that CPCTC whole thing. If you know that corresponding parts of congruent triangles must be congruent, you are good to that point. All right? So, all right, so on this side, I'm going to walk you through number 2, and I want to see if you can try to do number 3 on your own. Okay? So for this number 2, I'm going to start with ACD being congruent to triangle BDC because that is given. So throughout this proof, I just want us to keep in mind that at the end, the thing we're trying to get to is to prove that CE is congruent to DE. Now we don't have a reason for that, but we will at the end. So we're trying to prove that CE is congruent to DE. Now I've been given that ACD and BDC are congruent. Now, when I think about congruent parts or congruent segments, I think of corresponding parts. So what I'm going to try and do is I'm going to trace these. I'm going to try and prove that ACE, triangle ACE is congruent to triangle BDE. So to prove those are congruent, I'm going to start by being able to assume a few things. First thing I can assume is that, or first couple things I can assume is that angle A is congruent to angle B because those are corresponding parts. Corresponding parts are congruent. And I'll talk about why I'm building that argument in a minute. So I'm going to start with that. Those are corresponding parts of the two overlapping triangles. So A is congruent to B because the triangle on the left, triangle on the right are congruent triangles. The next thing I can assume, and I'm going to keep this in the same line, just do it in the same color, is that AC is congruent to BD because those are also corresponding parts of these two overlapping triangles. So of ACD and BDC. So I'm starting to build my case for the left ACE and BDE being congruent. The last thing I can say is that angle, do it in green, sorry, angle AEC is congruent to angle BED. And the reason I can say that is our good old-fashioned vertical angles. Those are vertical angles. So through all that assumption, all right, what I can say is that triangle ACE is congruent to triangle BDE. And this is going back in our memory banks. This is by AAS. AAS. Angle, angle, side. Through all of that, I can now say CE is congruent to DE because those are corresponding parts. I'll write that better. Corresponding parts are congruent. So that's about the extent of the proofs I would give you. Now, if you go down, you're going to see example 3. It has a proof that has 9 steps. I don't want to cover these steps in a video. I don't think it's going to be helpful. I think it's just going to serve to frustrate you. So we would probably cover example 3 on Friday, because I'm basically just going to go over this lesson a little bit more in depth on Friday, talk about more of what I expect for you to have down and for you to review to be ready for the quiz. So this example I'm going to hold off on doing until Friday. You're going to have a practice. You're going to have some things I want you to do. I want you to complete those so that you can feel comfortable going into the quiz next week and understand what I expect. So the practice does a pretty good job of throwing some proofs in there, throwing some problems that contain overlapping triangles that should get you enough understanding to be able to do the checkpoint at the end of this lesson.